Welcome to this episode of the AEC Engineering and Technology podcast dedicated to helping engineering professionals find technology to fit their needs. In this episode, I'll be talking with Dr. Ali Khaloo, the CEO and co-founder of Aren, about how you can bring digital twin and artificial intelligence to infrastructure asset management. Okay, let's get into today's episode. Okay, it's now time for our conversation of the week with Dr. Ali Khaloo, the CEO and co-founder of Aren. Ali, welcome.
Hi, Nick. How are you? Thank you so much for having me.
Absolutely. Great to have you here with us today. Do you want to start off and just tell us a little bit about yourself and your company, Aren?
Absolutely. With pleasure. So a little on myself, as you mentioned, Ali Khaloo, and so I'm the CEO and co-founder of a tech startup called Aren, which is a startup based in New York City. And the way that we, wind up starting this company was it goes back into my background. So I have my, education all the way to Ph.D. in civil engineering, and for my postdoc at Cornell was all about artificial intelligence and mixing that with civil engineering knowledge. So, but at least I've seen on the educational side of things and academia was, we have all these super cool technology from sensors and, the accelerometer, tilt meter, drones, whatever that we have at our disposal. But what happens is we don't do a good job in terms of analyzing all of that data. So all these data is like living in their own silos without communicating to each other. And when you're looking at the way that we are adopting technology, as an industry, we're not so good at it. So it's like the second, when you look at how digitized our industry is, I think it's only above hunting. So that tells a lot. So what happened with us is, so we started this company with this whole goal of improving two things. One was helping with, optimize the spending on the assets that we are using on a daily basis, and also reduce the risk of failure of civil infrastructure assets. So as a company, what we do is we are creating this software as a service civil infrastructure management platform to help both the engineering firms and the asset owners to assess and manage their heavy civil infrastructure assets. And that can be bridges and buildings and dams and parking garages and et cetera, et cetera. And what we do is we are uniquely combining AI with civil engineering to do that job for them. So essentially, in a nutshell, we are building this digital health record of the assets through time. So when you're looking at our product and our technology in the simplest of forms, we get information from our clients, and that can be images coming from smartphones and digital cameras, and you can get more sophisticated and throwing drones and laser scanners and subsurface sensors such as infrared or impact echo and whatnot. We get that information, that all of that gets uploaded into our cloud-based solution, and then our magic kicks in. You're running our proprietary technology, which we have several international patents on it, in order to turn that information into a highly detailed visualization of the asset and its health through time, as well as preventive maintenance plans and capital allocation plans. So that is the not so short answer in terms of who am I and what we do at Aren, but I hope that provides a good background.
Absolutely. And I think if you're going to summarize, right, so intake of this data from multiple sources, right, whether you said it be a phone camera, a digital camera, maybe some non-destructive testing equipment, 360 cameras, right? It's all data, right? Yeah. And it all comes together. And I think, as you and I discussed earlier, a hot topic right now is digital twins.
Yep.
So could you tell us a little bit about, from your point of view, what is a digital twin and how does a digital twin work in terms of asset management?
Absolutely. So, I mean, you're seeing that different industries and different people use that terminology, digital twin, differently. At least the way that I want to look at it is, in the simplest of forms, it is a digital representation of a physical world or of a physical asset. And the goal here is not just to have the digital replica, but you want to use in order to reflect whatever happens on the asset on that digital twin or digital replica. And the whole goal is to use it for, for different kind of simulation and testing and monitoring and maintenance. So essentially, that model wants to serve as the reference point of how you're storing all the information of that asset and how things are changing and evolving through time to get, to have a close, to be able to closely monitor what's happening on your assets. So in the case of asset management, we have all these, assets around us that we're using on a daily basis. A good number of them are pretty old. So what you want to do with digital twin technology is to have this digital replica of that asset, and to be able to, at each point in time, go to your model and understand how things are changing at that asset. Is it a building, you have settlements, or is it, a bridge or a dam? Do you have cracks propagating through time on that? So all of that information is what you want to centrally host on that digital replica.
Yeah, excellent. And you've kind of stated, making me think about, right, some of the ways that I've heard digital twins being used, right, the different types of data that are made available. But what would you say are some of the ways that a digital twin can improve the O&M or operation and maintenance process, right? Because from my point of view, there's the digital twin for inspection. But for asset owners, right, there's a whole nother world out there where maybe they're trying to operate and maintain an asset from a scope that, say, I as the engineer am not thinking about. So what are some of the ways that you can do that from the asset owner side?
Absolutely. So before jumping to answering that question, let's look what is the status quo, and then how all of this can change that. So looking at the status quo, the way that we're gathering information of our assets, it's safe to say it's precarious and outdated. Still, we're sending inspectors, like highly trained inspectors, out in the field, and what they have to do is they have to climb and walk like miles and miles of infrastructure, and now they have to use their naked eyes to look for millimetric issues and document that while they're in the field. Basically take a couple of photos, write that on a piece of paper, and now they have to go back in the office, put together a report, put together the drawings of all the damages. So as you can imagine, that whole process, it is tedious. It takes a lot of time to do that. And even more importantly, it is subjective and inconsistent. And there are well-written reports, looking at the bridges, for example, by Federal Highway Administration, FHWA, that the rating that, one engineer gives versus the other one can vary a lot. So there's inconsistency built into whatever we do. And what happens is that inconsistent data is what we feed into our decision-making processes to, either, let's say demolish a building or replace different parts of the assets or doing the repairs and whatnot. So you have this inconsistent information and poor information coming in to make this trillions of dollars of decision-making on top of it. So, and because of that, no wonder that there are again, another studies out there by companies such as McKinsey that 40% of the infrastructure spending is poorly spent because of lack of technology. So now let's get into the digital twin and how that can change. So what is happening, you mentioned about the digital inspection per se. So what happens now, it's now by using new technology, which is a good number of them are remote sensing based, meaning you have digital cameras and your cell phone, of course, or smartphone, 360-degree cameras. Now that is so easy to get good quality visual data captures sources. So what happens now is, first you can go from having a couple of photos from the asset to actually having thousands of photos, or minutes and minutes and minutes of video of that asset, which now that serves as this visual representation. Now that holds the actual truth. So it's not the handwritten notes of one engineer versus another one, which now you can debate, maybe one did a better job in documentation versus the other one. No, now you have visual data that you can always go back to it. So From the inspection point of view, several things can happen. One, now you have this data that holds the whole truth, and you can always go back to it. And now you can actually, after going to the field and coming back, you can actually, let's say, open 3D models, 360-degree videos, and do some sort of a virtual inspection. So you can, while you're in your office or at your home office, you can log into whatever platform you're using, and you can look at that data and go through it and make sure that you captured every single thing there. So from the inspection point of view, it's just going to be easier and getting to more consistent. And of course, if you add a layer of AI, which we're going to get to it, now you're adding objectivity to the whole thing. From the asset management point of view, which is a higher level, now if you have, let's say, all of the asset managers or owners, they have a portfolio of the assets. So it's not just one particular building, one particular parking garage or a bridge. It's like hundreds or thousands of them. And now they have to make decisions in terms of capital allocation. So if you are getting good information of every single asset, granular information, you know exactly what is wrong with each and every one of them. Now, when it comes down to your asset management, now you can make a way better decision in terms of how you deploy the money, in terms of improve the health of some of your assets, targeting and going after the ones that are in dire needs of attention. So now you're starting to get, optimize the amount of money that you have versus the way that you were decision making before, which was all this, inconsistent and subjective data coming in.
Which is a great point, Ali, because right, that objectivity of the data, right? Because photos don't lie, right?
Yep.
And in the vast majority of cases, right, you're taking a picture and that picture tells you a story, and there might be some interpretation to what you see, but there's definitely less interpretation than traditional engineering methods, like you said, handwriting some notes on a piece of paper, or a verbal conversation of, hey, I'm seeing this, right? But there's definitely a lot more to be desired for what we're doing now as an industry versus kind of what you're proposing here, right? So you've talked about some of the benefits of digital twins and asset management. We also touched a little bit on AI, but could you talk about some of the challenges and the risks that are associated with digital twins and AI in asset management?
Absolutely. So, as we discussed a little bit earlier, for the digital twin, you need to have good data sets. So one of the issues or one of the challenges is incomplete data sets. So right now, again, going back to the status quo, you go to a parking garage, or you go to a building or a bridge, and you maybe have a handful of images and a handful of, handwritten notes. And that, yes, it tells you a story, but it doesn't give you the full story that what's going on. So that is, like, I think one of the things that has, it have to change as we move moving forward, in a sense that we should cover our assets, and in a sense that you completely capture the information. And that doesn't mean that you have to now spend more time. It's actually using a different tool, like a 360-degree camera. Just walk by, it captures everything on that asset, for example, or send a drone and it can, cover the entirety of that asset and give you what you need. So that doesn't mean that you need to spend more time. So I think the incomplete data set, and that's a challenge which we have to overcome. We have to sort of implement within our day-to-day and work from the engineering side of things to capture better data. I think the other piece is, as we discussed, it is important to keep and store all this data that we capture in a centralized manner. So the last thing you want is to have this issue of dark data, meaning you have images in one place, and then you have NDE data in a completely different place. And as we know, even within NDE data, sometimes they're giving you contradictory results. Sometimes the GPR says something which Empatico says something else. So just having all of that information in just one place and process them as a whole, that is the only way that you can get a holistic view of what's actually happening in your asset on the surface, on the subsurface, and start to like literally monitor that over time. So I would say after the incomplete data that we collect, it's going to be the dark data, lack of centralized data management. And the last thing is regarding the AI that you mentioned. So one of the things that we are so proud of it is we are coming from the industry. We know how engineers work. I mean, I personally designed buildings and bridges. I did rehabilitation designs. Like I know what is that process from the get-go. And so what happens is with some of these AIs that you're seeing out in the market is they're sort of like they built them in silos. So they're like very much apart from reality. Some of the, a good number of those companies out there, they're developing AIs and they're like coming from computer science background and they're like very much a generalist. So they apply AI to building environments or built environments. They also apply that for vegetation monitoring and crop monitoring in agriculture. So they apply AI to everything. But in our case, in our industry, given that it is, as you mentioned, is one of the least digitized, and they're a little bit technophobic, you actually need to build something exactly for their need. So it should be exactly, in terms of the way that the technology works and the way that you're providing the results to the engineers. All of that should be, something that should work hand in hand. And I think that building AI in silos apart from reality, that is another challenge that as an industry we should overcome.
And great response, Ali. And it's, and to your earlier point about, right, this incomplete data set, right? Because how many times are you're running across firms where, right, it's a digital camera, it's a piece of paper and a pen, right? And there's spot photos where there's suspected to be issues, right? But we're only human and we only have so much time and can only document so many things, right? And the promise behind digital inspection and now AI is, right, like we talked about earlier, it's right. It's like Tony Stark putting on the Iron Man suit. It's not here to replace us. It's here to help us and do a better job as engineers. And in fact, there are ways in the data collection where you as the engineer may actually end up doing less, right? Because there's simplified ways to collect the data for your review, right? Almost like a doctor reviewing an x-ray, right? They may not be the ones to take the x-ray, but their expertise is used to then interpret it, right? So perhaps there's a similarity to medicine kind of in our field, which is very exciting, right? Because as we talked about earlier, engineers are asked to do a lot. And the premise of technology lightening that load on them is really just fantastic.
Yeah.
But let's talk a little bit about data, right? So we've talked about asset management firms, right? How they're using digital twin and AI, but can you give some examples of data analytics specifically? Like how are they taking everything that they've gathered, right? And let's say a digital twin and then using that to make decisions?
Absolutely. So as we discussed, now we are living in an era that having different kinds of sensors, it's so easy. It's cheaper than ever before. So now you can capture a lot of information, and that can be, I don't know, from 360-degree cameras and drones and laser scanners to, strain gauges, accelerometers. All of that is just cheaper than ever before. And setting that up, getting this data, it's easier than ever before. But now the big thing, or the natural next step actually, is you have to analyze all of that. And again, as human beings, analyzing a whole lot of data coming from different sources, it's not our forte. It's not the thing that we are very good at. Mm-hmm. So the natural next step is to now have computers do that job for us, do that repetitive job, because computers never get tired. You just run something overnight. It's always going to give you the same exact result versus a human being. Let's say you're out in the field collecting data and like inspecting an asset. You start 7 a.m. I'm sure that information captured at 7 a.m. versus 2 p.m. are going to be different. So the AI starts to give you, not only help you on that repetitive task, it also helps with objectiveness and consistency. So now you're getting consistent data from all the assets that you have in your portfolio. And in terms of in what manner that you can use it, first it can be, now the AI can go through all that information that you capture and pinpoint all the issues and say, hey, these are the, and this is all probability game. So it tells that, hey, with 95% accuracy, I'm telling you on these exact locations, you have cracks and you have spalling and you have voids and you have this and you have that. So it's just identifying different issues, and that is like helping on the inspection or condition assessment side of things to flag different issues, to quantify different issues and say, okay, I see a crack here. This is the length of it. This is the width of it. And then, you run a severity analysis. So based on the location of the issue and based on the type of material, type of the asset, we all know that there are codes out there that tell you exactly that if you have this crack with this, certain characteristics, it is a severe crack, or it's a fair crack, or it's a poor, or it needs dire need of attention or not. So that's on the inspection side of things, just to get that consistent information in your condition assessment, and this like list of damages and all of that. And on the asset management, again, you need to do two things. One, now that you're building that, as I mentioned earlier, that digital health record of the asset, now you can start to get into predictive analytics. Now you create that, you update that digital twin over time, and now you get to a point that you can say, okay, this is how my asset is behaving, and this is how it is, for example, degrading over time. If I don't do anything, in the next 5 years, I'm going to have a huge issue on those certain spots. So now with that predictive analytics that you sort of like built up to it, now you can tell what's going to happen next, and that's going to help you in terms of, okay, how you spend your money. And again, and that's like start to get to optimization. Basically, you're saying, hey, again, I have 1,000 bridges, I have 1,000 buildings. If I don't do anything, these this is what's going to happen to them in the next 10 years, and or these are the ones that need dire need of attention. So right here, right now, I have to actually pull a lot of money, because if I don't do that, something catastrophic is going to happen. So that is the way that the AI can help on multiple fronts, from the inspection to the management. And again, as I said, that is the natural next step with all the data that we can collect in this day and age.
And the overarching theme here, Ali, right, is like you said, so humans have a very specific skill set that we're good at, right? Rote data collection and analysis is not it. But being able to recognize patterns and issues from this 30,000-foot view, right, aided by technology, is what we excel at, right? So again, it's putting in the case of an engineer, right, putting that engineer in the best spot to make the most out of the data that's been collected. And for the asset owners, it's understanding what everything looks like kind of at this global scale, instead of just the single asset that's right here, and optimizing dollars and doing everything that you've talked about to, at the root of it, right, make better decisions. That's what it comes down to.
Absolutely. One thing that I always like to emphasize is this is all going to augment the process. This is not meant to replace the engineers whatsoever. You want to have engineers in a situation that they have all the information needed for them to make engineering judgment. Right now, with just bits and pieces of the information, not having the full picture, they have to make decisions. They have to, make up their mind in terms of what to repair, how to repair, all that kind of stuff. But you want to give them all the best tools out there and all the information, full picture. So now you're just making the decision in a data-driven manner. So it's less of guesstimating and anything of that nature. So it's just going to augment the process. And as a matter of fact, when you start to take out little by little, take out those repetitive tasks, now you can actually do more. So if the engineer can, let's say, inspect and then put together a report and provide recommendations for one asset per week, I'm just, as an example, now they can do like 3 per week. So now they can be more productive. And you're looking at from different perspective. The engineer going to be more productive. It's less doing the cumbersome work out there or repetitive jobs. And also you're looking at from the business side of things. Now, as a firm, you can take more jobs. And again, that's more revenue. Also, on top of that, now with technology, you can go after jobs that, for example, before you couldn't do it because it was like humanly impossible. Like, for example, we had this conversation, like crack mapping of a 3-kilometer long bridge. That's almost humanly impossible. Like, it's going to take months and months of work to just crack map the entire bridge. So now when you have that technology, now even as a firm, you can go after those jobs. So that's even new revenue for you. So I think there are different ways of looking at how this disruption, if you will, can actually help you in do the job faster, get more things done in a safely manner, and also make more money.
And it's all about getting ahead of those trends, right? And one thing we touched on earlier was, now that you have this centralized, data storage, right? The dark data is becoming less and less, right? Whether it's stored on somebody's desktop or lost in some folder on some some server, right? Now
Absolutely.
you can start, even with the AI piece, right? There's still going to be tasks that humans need to complete, but now that data is all in one place where everybody can access it, right? Perhaps there are some tasks that even that engineer may not have to do, and maybe their output of reports per week can go up, all while working the same or less. But let's stay on that topic of that engineer, or more broadly that AEC professional, right? So
Yeah.
what are some things those professionals, whether they be individual contributors or leaders within their firms, right? What can they do to harness the kind of the power of everything we've talked about today, kind of in their day to day?
So one of the things is, as we touched upon it, as an industry, we are one of the least digitized ones. So one thing that you always want to find is within different firms and within the whole landscape, you want to find the innovators, you want to find the early adopters, so people that see it is an issue and they are looking for innovative ways to tackle that issue. So sometimes, and we all know that at the end of the day, most of the decision making is in the hand of the asset owner, that they have to, they're the one who's going to stick with that asset for hundreds of years, and they have to pay for every single service that, for example, the engineers are providing. So I think one thing we should realize is, apart from the fact that what is the need from the owner or how urgent that need is, I think one thing that we have to all agree upon is infrastructure and built environment and the state of them. It is a big issue. So sometimes I like to make this comparison that it's like climate change. So early 2000, it was a big thing, and everybody was like, and start to, like, even venture capitalists start to put a lot of money, and entrepreneurs start to work on it. But then, like, since nothing that much happened on the tech side of things, like, everybody was like, oh, why nothing happened? Why I didn't get the 100x or whatever. So, but the issue was always there. Like, nobody can debate that the issue is not there. So I think that's number one. Like, we should accept that we have an issue globally on the way that we are dealing with our built environment. So the next task is that innovators, that early adopters, like people that are like, okay, I'm going to actually go ahead and propose this to the asset owner, because at the end of the day, it is in their benefit. So that is a collaboration from the tech companies with, in conjunction with these engineering firms. So that's kind of, talking about how that you can, something can get facilitated here is that, open up the opportunity in the sense that the consulting engineering firms and tech startups acknowledge that there's a need, there's opportunity, and let's actually together go to the asset owner and show them what are the benefits coming out of this, and essentially asking for what I like to call a reference account. Like, hey, give us, for example, one parking garage, one bridge, or one build, whatever that asset is. Let me show you over the next 6 months what you can get out of this technology. So just, showing that how things are in their benefit and how this can change the way that they're taking care of their assets and they're spending the money. I think that's the way that this industry is going to move, by just literally showing them. But it all starts with, like people start to put people in front of the decision makers, and that willingness of sharing data.
Agreed. And you touched on a great point where until something's like right in front of your face and you truly realize the magnitude of the problem, which unfortunately in kind of the civil infrastructure world comes through failure, right? And it makes headlines, and the public gets concerned about the state of what's going on.
Yep.
The one of the bright sides is that it opens up the conversation of we're not doing the best job that can be done, and how do we do it better? And I think we're kind of in the golden age of that partnership between the engineering firms who traditionally serve those asset owners, and now technology companies that can come in and make the engineer's job, or any AEC professional for that matter's job, simpler, right? And it combines everything we've talked about, right? Data's cheap, access to sensors is becoming less and less expensive, and it's all kind of coming together to this golden age of being able to ultimately service the built environment better, which is really exciting. And then I'll say, touching on that note of the engineer, the AEC professional again, right? Say one comes to you and says, hey, I really like the idea behind what you're doing. I'm just concerned for what that means for my future, my job prospects, right? Is this technology going to replace me, or what exactly will happen? Like, what are you saying to that person to kind of comfort them?
So one of the things that has happened with us in particular was, in the past, few years working with different clients globally, I would say that for those people that come in with those kind of questions, now we have data showing that what is the benefit for them? Like, we have the crystal clear, basically, value proposition for the AEC firms, in a sense that, okay, now, yes, we don't play the efficiency game that much per se, because just efficiency, it's usually not moving things that much. The way that we play the role is hey, by just using this technology, you can increase your revenue, and we have like hard data to support that, in the sense that, okay, now you can take on, for example, projects that you couldn't take on before, because it was like you should bill by hours. Something would take you hundreds of hours, then it starts to be like something humongous of a task that you cannot even put it in front of the asset owner. Now with technology, you can actually do that, take on those jobs. The second thing is just adding to the competitiveness. So now you have this extra piece that you can again provide for the asset owner, which that helps in terms of getting more jobs as a firm, and again increase the revenue. And then the last piece that we are playing around is, so one is new revenue, completely new revenue. The second one is like whatever cash cow you have right now, it's just helping you with just increasing that. And then the third thing is, okay, efficiency game. Now you can do things more efficiently and just better than before. So those are, and again, we have like hard data to back that up with, like, hey, this is like 20% increase, 30% here, 5% there. Like, all of that information, something that all of that, let's say, return of investment, ROI, something is that we documented over the past couple of years. So that's what we usually walk them through. And we've seen that usually increasing the revenue and help on that front, it's a better motivation than, oh, it's just efficiency gain.
And we've talked about it on previous episodes, right? We have even articles written on the EMI blog about it, right? But it's all about communicating to your audience, whether that's an asset owner, right? Whether that's the owner of your firm or a principal, kind of right, as an individual contributor on the professional side. What are they interested in? What's in it for them, right? So like you mentioned, revenue is a great piece of discussion for any business owner, because that's something they're actively going to try to increase, right? And just being able to craft that message for the specific individual that you're communicating with is huge. And it's good to see that you guys have the data to support it, because so many times, right, on the technology side, we get, and I'm guilty of it as well, as we get so lost in how fascinating and how groundbreaking the technology is, but then forget what message we're broadcasting and who we're ultimately talking to.
Yeah. And that message should be, it's different for different stakeholders. So you have a certain, ROIs and values that you have for the AEC firms, and then for the asset owners, it's just different. So for example, for the asset owners is, for example, limiting the amount of change orders whenever you're doing repairs, just, helping you with the repair cost, because now you're identifying things, sooner rather than later. So it's not like everything you have to wait till everything is like almost falling apart that you go ahead and fix it. Now, with this kind of technology, you get the full picture. We can actually do minor repairs here and there to improve the health of the asset. And because now you're doing it sooner rather than later, within the life of the asset, it's going to be cheaper for you. So now with the asset owner, it's all about, okay, reduce the repair costs over the life. And at the end of the day, like minimizing the life cycle cost of your asset, because now you have different data. So again, for each stakeholder, that message should be different to get the buy-in from them. And the best thing is to have hard data to support that. And that's one of the key things that we have been focused on, I would say, in the past year or so, in terms of documenting all of that information. So whenever we're in conversation with an asset owner or an AEC firm, we can actually provide that information to them.
Yeah, absolutely. And at EMI, right, it's all about being, as kind of from the engineer's point of view, a lot of the content here focuses on just that clear communication and going beyond, let's say, the numbers or the engineering or the technical, right? And this is a great example of taking all of that, but then condensing it down into a message that stakeholder understands. But Ali, it's been a pleasure getting to know you more and getting to talk about Aren and kind of the theory, the data, et cetera, behind it. What final piece of advice would you like to give the audience today?
So first and foremost, thank you so much for having me. It was a pleasure talking to you to discuss, how we can use digital twin and AI for infrastructure asset management. In terms of like piece of advice, I'm usually not very good at giving advices, but it's just be more open to technology and educate yourself more on the latest and greatest things that is happening. I see that all over the news you're getting information regarding artificial intelligence and autonomous vehicles and this and that, and people get excited without knowing that some of those pieces of technology that, for example, you have in an autonomous vehicle or you have in Teslas of the world and stuff like that, same thing can be applied for civil infrastructure management and inspection, like that kind of a AI-based visual assessment and understanding, like finding certain areas of interest, let's say damages. It's similar with artificial intelligence built in autonomous vehicles. So all of those, let's say, cool technology out there that everybody get excited, we can actually use it in our own industry. So I think that starting to connecting those dots, that this is the same technology in autonomous vehicles that is all over the news, now can be applied to my day-to-day job, understanding that, yes, it is on us as tech companies to educate, let's say, the industry, but having the industry be more open to technology and sort of, educate themselves on it, I think that'll be huge.
And it all goes back to, right, as we always say in engineering, first principles, right? Just this is some piece of technology, it does something, right? And how do I apply it to my specific situation? And I'm 100% agree. There are a lot of just low risk ways to get yourself involved and educate yourself on technology without really disrupting your day to day. And step by step, I think many individuals and firms will find that it's a net benefit and it happens pretty quickly.
Yep.
But again, Ali, thank you for joining us. Where can our listeners find you today? Whether it be on social or email, like what's the best way to reach you?
So of course, they can go to our webpage, which is aren.ai. That's our company webpage. We also have a page on LinkedIn, and of course, myself, I'm on LinkedIn as well. So I'm always active, always in response to the messages coming through LinkedIn and through our own company webpage in terms of the emails that we receive. So happy to chat, happy to talk about technology, happy to talk about what you're building.
Wonderful. And we give the kind of the same offer, right, to our listeners. If you have any questions about, today's episode, right, technology in general, we are here to help, and we try to do the best that we can at EMI to provide that experience and that really just that helping hand, right? Because we're kind of all in this together as an industry and just want to help each other out. But again, Ali, thank you so much, and it's been a pleasure.
Likewise. Thank you so much.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you all the best in all of your engineering and technology endeavors. Thank you.